In this second video, I'm going to show you how to do data analysis by using a macro in ImageJ that I developed for this project. That macro essentially makes data processing very simple and relatively fast. So I'm just going to demonstrate. I have my setup ready, and as you can see, we can see our Ruby sample. The gain is quite high. I will reduce the gain to 0, and then I will start capturing. I will extract the Ruby sample and stop the capture. Now I can see that my frames are captured and they are here. The first step is the same what we did earlier. I will rename these files. So I have my advanced renamer ready. I don't need this file, so I can delete it. So I will drag all the files to the advanced renamer. My files have now been renamed. So what I will do is I will open ImageJ, and if I go to here plugin and macros, now I will go to install macro. This file macro ruby version 3.igm is provided in the supplementary information with the paper, so you can just copy the file and install that. And after the macro is installed, when you go to macro, you will see this macro ruby v3 in the bottom, so simply click here. Now in the data path, you browse to the folder where all these frames are stored. So I know my frames are stored here. And there are the number of images in this run. I know there are 1412 images, and I can simply hit OK. So after all the files are analyzed, you will see this prompt that draw region of interest and closing the Ruby sample, and then hit OK. And you'll think, okay, what to do, what is going on here. So if you just move this prompt apart, you will see an image behind, and there will be essentially it will be one of the initial frames of the Ruby. So all that you have to do is just make a region of interest like this, square or rectangular, which encloses your Ruby sample, and then just hit OK. After that, it will analyze all of these frames, and you will see a log prompt where there will be time versus intensity. And the next prompt will ask you to do the exponential with offset curve fitting, and then hit OK. So what you have to do for that is, you will see these are the times, and on the right side are the intensity. What I do is I look at the maximum intensity and I just start from the next one, because the maximum intensity usually have some influence from the flash. So I copy all of this data into the curve fitter. Paste it here and select exponential with offset and simply press fit. Here my fit curve is shown. R square values look very good. This is my B, which is the decay rate constant, and if you look at the C offset, which look very close to what we have in the data here, about 1115 here. So everything looks good, and I will just hit OK. After that, it will make a video to visualize the fluorescence decay. So the video is ready here, and it's prompting you to save the video, and it is asking in the video what kind of compression you want. I can say none, and at what frame you want the video to be played, and I just say here maybe something like 5 frames per second, and just hit OK. Then it will ask you where to save the video. I usually just go to the same folder where all of my other data is stored, for example here. So when you will go to the folder, you will see there is a new folder named result. The result folder has the screenshot of the fit that you had just made and the decay data in an Excel sheet and a Word document, and in the same folder I can save my video. So that essentially concludes the data analysis part of it. You can close rest of the ImageJ prompts, and if you go to the result folder in here, you will see there is a new folder results. So there is a fit plot already here where all the parameters can be seen, and the same fit data is in these two files, and this video file essentially show the decay of your Ruby fluorescence that you can essentially just load and play with ImageJ.